Alright, so before I tilt the head back up, I've got it actually in the transit position, if you want to call it that. Obviously, if I was keeping this machine for myself, not just using it for a parts machine, I would not have done it this way. I'd have a wooden block underneath there to protect the table. But I'm going to show you this table up close in a minute. You'll see why the table is not any of my concern. My table's in better shape. On the underside here, you can see where this has gotten biffed pretty good, and quite a few layers of the original finish have been just cracked right off. And that's from when they went to move this thing out of their shop. They used their fork truck, and they put one of the forks right under here, which is a no-no. Because the reason why they did that was because the ram was all the way back. What they should have done is what we did when we were putting the thing on the truck, which is I moved the ram forward so that you could get one of the forks under here and the other fork under here. That's how you want to lift this thing. And then you also want to put wood blocks under here and there to protect it. We didn't put the wood blocks because, again, I'm not interested in protecting this ram. I don't think anybody's going to be looking for a replacement ram, and if they are, they're probably not going to be local enough, and I'm not willing to ship this thing. So unfortunately, that probably is going to go the way the body of the thing's going to go, and a lot of the other parts, which is the scrapyard. And I got some biffs on the top here from the loader when I was just unloading it. Alright, so let's rotate that head up a little bit. Alright, so you can see the sins of the machinist here. We've got a cut mark going across here where the end mill was in contact with the table, and somebody moved the table back that way. We got a nice big cut right here. I don't know if they had a huge end mill or what they had on there. Got some drill holes, and then the worst one is back here. There's a really deep gouge. That's like at least 1/8 of an inch depth at this end. And you can see it started shallow here, and then the cutter dug in and it went all the way across to here. And then, to add insult to injury, they did it on a second pass because you can see there's a deeper cut. There's another ridge there. So I don't know if the end mill was coming out of the collet or what they were doing there, but that's pretty nasty. So this table, going to probably end up scrapping this table, or more ideally I might see whether or not anybody wants to turn this table into a poor man's welding table. I've seen some guys make a frame out of angle iron to sit this thing on, and then basically, because it's got all these nice T-slots in it, it's a handy thing to clamp parts down to when you want to weld. But right now what I want to do is I want to check out this couple other things on this mill. Alright, so I got a spare handle here for the knee, which is unique to the Wells Index. This one only has one of the 2 pins present, but it actually still works. So I don't think I'm going to need another handle, so that's probably going to be an eBay item. This hand wheel is loose, but it's actually not broken. And this hand wheel over here, the plastic handle is broken, but the hand wheel itself looks good. It's got the auto feed on it, like mine does, so this button here should be for the rapid traverse. We're going to test that out in a minute, because if that works, then that's going to be something somebody might really want. I don't know whether or not this could be adapted to be used on another machine or not. There's a one-shot oiler on here, and it's the Bijur, the same one that's on mine, and the reservoir does not look broken at all. As a matter of fact, it's even got oil in it up to here. So, you know, if I knew I was getting that, I wouldn't have shelled out the money for a brand new reservoir for mine. So I'm not sure what I'm going to do on that yet. I'll probably end up just putting the new reservoir on mine and selling this as a complete one-shot oiler. Again, another eBay type item. This big bracket here looks foreign to me. That must be, oh okay, that's the reed head for this scale on this side. So hopefully that's gonna, hopefully I've got holes where I can actually mount that on my machine. Otherwise, I'm gonna have to drill and tap some holes on there, and that might be a little tricky. Alright, so the motor, I've got the motor off because it's a lot easier to transport it with the motor. The motor adds a lot of weight up top and kind of makes it top heavy. Flipping the head up and down is a lot easier with the weight of the motor off of it. So there's the motor. The motor sounded good. I'm going to have to do a side-by-side run of that motor versus my motor. And whichever of the two motors is quieter and sounds nicer is going to go on my machine. And the other one will be a good used motor for somebody. That motor looks pretty specialized. It's the Doer, D-O-E-R-R, I think, motor is the name of the company. Alright, so let's play around with the Rapid Traverse. Since that runs off 120, we can just plug it into an extension cord out here. Go ahead, Aiden. Go ahead and plug in that plug right there. Plug that in. Alright, see that black lever there? Flip that black lever.
Where?
Either way. Not doing anything, huh? Alright, hold on. Well, this thing's dead as a doornail, and then I just looked at it a little more closely and realized that I think what I'm looking at right here is a fuse holder with no cap on it, no fuse in it. So, and it's cracked and broken, so that's probably why they couldn't put the cap on it. So it's going to need a little bit of attention. But it might be worth still messing with because, you know, a good running feed table, whatever you want to call it there, you know, those can bring some decent money on eBay, whereas just a parts one that's broken and has, you know, no idea whether it's any good or not, that's not going to be worth much at all. But that's going to be, you know, something like throw in a box and become the project down the road. Alright, so I was just going to take this scale off the front there and was hoping to keep it intact, but looks like I'm going to have to take this protective cover off because there must be another screw in the middle there somewhere, or one or two that are hidden behind this cover, because I just took the two end ones off and that's not budging. It's still pretty attached to the table. Well, no, I don't think there is another screw behind there. I've got the thing rocking back and forth, but it appears to be hung up on the reed head, so it almost seems like maybe the reed head sticks up in there and... Well, there we go. Well, the good news is the glass isn't broken. This is, I saw somebody took one of these apart on YouTube and they pointed out the fact that, see this, what I'm pointing at right here with my finger is actually supposed to be foam. And that's completely gone the way of the dodo bird. So, what it looks like I should have done, no, I couldn't have done that. Yeah, I should have left it mounted on the table and then taken the cover off and then taken the reed head off. So I got to take the reed head off next. Whew, this reed head assembly is super delicate. So what I'm going to do now is I'm going to remove, there's a screw right here that's holding on a strain relief that the two cables go through together. Before I remove that, I'm going to cut right next to it in front of it. There is a wire tie that's binding the two cables together for the two axes, the two different scales. So by cutting that, once I take this screw out, I'll be able to take this reed head assembly and its cable separate. Matter of fact, there's several of those ties there. I'm going to separate those completely. I can always put new wire ties on later. And just for my own reference, there's another one over here that goes over to the scale on the side. Another little strain relief or cable holder. The change of plans. I'm going to keep the two cables together, and I'm just going to undo that that reed unit on that side and keep that all as an assembly. Just not sure how I'm going to keep that from getting damaged. I'm going to have to find a container to put all this in, coil the cable in there with it. And I'm going to put that cover back on the glass scale to protect that. See all the swarf that sat on top of that, and then all the swarf that fell down between the back of the scale mounting and the table and has been stuck in there for who knows how long. So right here you can see this is the remnants of that foam. It's just completely dry rotted, as would be expected for something from back in 1983. But I'm sure I could find a little strip of foam to replace that. Hey, this optical scale actually has a label on the bottom of it there from Dynamics Research saying exactly what model number the scale is and the serial number, but what's really nice is that it's actually got a little bit of information telling me that what the wiring is. Channel A is white, white/black. Channel B is green/green/white, and then channel Z is blue/blue/white. 5-volt is red, common is black. That's going to come out. That's going to come in real handy, I think, when I go to figure out exactly how to fix this wire, the cable that was ripped out of the back of the plug. This is what the plug's supposed to look like. It's a one of these type that actually just slides onto the edge of the PC board, so that the foils on the PC board act as one of the contacts. This is what the other one currently looks like. You know, and actually the little pins are still on there. I might even be able to get that all back in there if I'm real careful. Alright, so the scale on this side is attached to this thick metal plate with 2 long Allen screws that have nuts on the back side. And then this big metal plate is attached to the side of the table right here with these large Allen head cap screws. So I think I want to take these screws out first. That way, when I take these out, I won't be putting the weight of this metal plate pulling down on that delicate head. Well, I just removed that metal plate, and boy, there's a whole pile of swarf that was stuck behind there, sitting on top of that head. And there's oil all over this area here, and I can see that there's a T-fitting right here for the automatic oiler right above this area. So any leaks at these joints right here in the fitting would probably cause oil to just constantly drip on that. So anyways, it's the big mouth on my 13-year-old. So it looks like there's a spacer right here. I don't know if that's just, yeah, that's just sitting there loose. Basically those screws are long enough to go through that plate and this big spacer, so that's going to have to go on my machine if I'm going to do this. Yeah, hopefully those holes already exist on my machine. Alright, so this is interesting. This bolt threads into this bracket, but this bracket is somehow mounted to there must be behind here, there must be a hole that I can't see that's got a recessed cap screw that bolts this to that. In other words, this screw doesn't go through this and into that. This screw only goes into this. Alright, so I took that scale off and just left the head on there, and I'm just going to take that all and put it in a bucket or a container and with the wiring and that reed head. And then, as I suspected, there are recessed holes behind here that were hidden behind the scale that actually mount these blocks to the side of the knee. And you can tell that this is the one that's going to go on the front because of the ghost outline here where the scale was. Interesting that on the knee right here there's a little boss or a part that sticks out proud of the side of the knee, almost as if like they intended you to be able to mount something there. So hopefully that's on my mill and has a hole ready to tapped and ready to go. That would be ideal. This little hole over here is completely filled with swarf. I'm going to have to clean this out. I'm going to get a vacuum cleaner and clean up all this stuff because I don't want all this stuff all over the ground over here. So I'm going to put together all my hardware and my scales and the cables and everything, store that away, probably pull the head off before it gets dark, or hopefully, and then I'm going to end up having to quit because it's getting late. Alright, so this specially cut bracket is going to have to come off too. This actually has a hole so that this is the saddle lock lever, can go through it. So I'm just going to unscrew this completely. Alright, looks like I got all the parts for the scales taken off the machine as far as the little auxiliary brackets and that go. I don't think I missed anything. Oh yeah, that one over there, the one that's, oh yeah, that's the one that all the swarf is stuck in there. Alright, so actually, I don't think I'm going to get the head off tonight, but it just occurred to me it's pretty easy for me to drop that quill and spindle assembly out of this head. So I think I'll just do that, get that inside. So that's basically, I got to take these two screws out here, that takes this little block out, and then I just wind this thing down. Alright, battery's dying, so it'll probably cut out while I'm doing this, but I took this little retaining block out. Actually, I took the screws out, and then that makes this block able to pop out. Talk around here in New England is the bumper crop of acorns we've got this year. And the squirrels have just been going nuts. So, I don't know if you can hear it, but every once in a while behind me there's a tree right behind me, and they're up there right now, and they're throwing acorns and shagbark hickory nuts and everything else in the area down on me. So now I gotta get that handle on. Now there's a spring inside here. Well, everybody, it's the next morning, Sunday morning, and I'm glad I decided to pull this quill assembly out of the mill last night, because it turns out it rained. As far as the rest of the mill goes, well, you know, the plan is to scrap it anyways, so I'm not really concerned about that. I think all I got left really to strip off that mill is going to be, well, I'll take the rest of the head off for any parts I might be able to scavenge out of that. So, rain's getting into that right now. Oh well. Anyways, I spun this, and unfortunately you can hear that's got bearing noise also. So, I was, you know, I guess I was hopeful that it was going to be even better shape than that. But when this is running in the machine, it was so much quieter than what my machine was sounded like. So I still think I'm going to just slap it into the machine the way it is and run it this way, because you know, the whole idea of taking this all apart, repacking the bearings with grease and going through that whole, I don't know. As I say it, I think about it, it's like, well, maybe that wasn't that difficult to do. Well, I do know one thing I do want to do to this before I put it in, and that's replace the broken pin for the collet here. I actually got the drawbar out, so if I pop something down that, I can get the collet to pop out. This is the dowel pin that I was using to indicate run out, and I didn't realize it, but somebody had turned this end of this pin. So when I was indicating here, I was about 5 thousandths out, and I was like, oh, that's not good. But then when I realized what I had done, I indicated here on the part that wasn't turned, and it's only 2 thousandths out, which is, you know, might sound like a lot for a precision milling machine, but I'm indicating on a dowel in a collet, so, you know, could be a problem with the collet, could be the dowel's not as round as I thought it was. So true test would have been to indicate right here on this. So maybe I'll do that when I get it in my machine. Hold the phone, hold the phone. Hey, the reason why I had such a hard time taking apart that last spindle assembly was because of the fact that, well, let me show you. I got the broken shaft right here. So here's the broken shaft, and you can see these threads right here. There's a locking nut that locks down onto the upper bearing here. Okay, there's a bearing here, and then there's 2 bearings down here. These are the 2 angular contact precision bearings. I don't know what this bearing is, I don't recall, but these are the 2 more critical bearings. So anyways, this locking nut is down inside here on my quill. So you got to have a special tool that slides down inside there, and I had to make something up, and even then I had a heck of a time getting that out, and it proved to be a whole nightmare. Well, I don't know if they did it on later models or earlier models, but there was, according to some of the disassembly instructions I read online, there were some of these that had a snap ring down there. And this one's one of the ones with the snap ring. So don't know how well it's going to show up, but if you look down in there, first you can see the telltale red grease, which is the correct grease for this application, but that's a snap ring. That's going to be a lot easier to take this apart, especially since I know how it goes together now. So I can get that apart fairly easily. I've got everything I need to clean it. I've got everything I need to put the proper grease back in. I really can't think of a good excuse other than being lazy to not do this right. Alright, I removed the collet, and before I do anything else, what I'm going to do is I'm going to hold the camera at approximately a foot away and pan down the length of the quill while I hand spin this so we can get an idea of the noise level. And then when I finish doing everything, I'm going to do the same exact test so that I can do a before and after comparison, and I could see just how much time I wasted. Hopefully not. So for anybody who didn't see me take apart one of these Wells Index spindle assemblies the first time, once you get the quill assembly out, first thing you got to do, of course, was remove the collet. Did that. First thing you got to do is remove this little tiny Allen set screw right here. This helps keep this big bearing retainer locked. You might not even have to remove it all the way. It might be just a matter of loosening it, but that hole was so dirty I had to dig a bunch of crud out just to get the Allen wrench to go in there. As soon as you take this out, you want to promptly discard that and lose it. Just kidding. Once that's been removed, now you can go about the what may be a Herculean task of removing this big bearing retaining nut. So there are two holes here, and what you need is what I could have bought at the used tool store last week and I passed on for $10, which was an adjustable spanner with pins on it. Yeah, that's just how that works. Didn't expect to need one, and then just kind of got cheap. Didn't want to pay $10 for it. Well, maybe if it's there next week, I'll grab it just for future reference. But in the meantime, let's see what I can come up with. On the other, on my spindle assembly, it had clearly been removed previously because the holes were all damaged and dinged up from somebody using a punch to tap it around to get it to unscrew. Alright, so in a perfect world, what I would want is I would want this tool right here. Okay, but this is the wrong size. Okay, so I can't use this one. And actually, the pins are actually too big. So whatever fits in here would have smaller pins in this, but have a wider spread. This is an adjustable one, but these pins are way too big. And the size of the head here actually won't even give you the clearance to get in there if you wanted to. Which makes me wonder whether or not that adjustable one that I saw. The adjustable one I saw was a snap-on, but it was just two flat bars. And it had two pins on one side. It was two flat bars and a scissor or an X configuration. Two pins on one end, two pins on the other end. That was, so it gave you two different sizes on the thing. So you could just flip it around and use it. But still had the problem with the flat bar not fitting in there. This is actually a pretty decent fit. I must have not had this sucker when I was doing mine. I think I had to resort to the hammer and chisel mechanic. Alright, so I think I can get away with using this. But the next problem is holding this thing while I put some force on that little wrench. Which brings up a valid point. This is a lot easier to do when it's in the machine, because the machine basically holds this steady for you. So I would say that that step right there is a step you want to do before you take the quill out. Oh, just happened to find this. This is the homemade bearing retainer nut sleeve that I had to come up with to take this nut that was on here off. Just reached down in there and was able to get these tabs to just engage it, and then grabbed onto this with a pipe wrench and was able to unscrew it that way. Well, if I give it a shock with a mallet, I might be able to get this to actually pop loose. If not, then I'm going to actually install the quill in my head, so I can do what I was just talking about doing, use the machine to keep it from moving around. I have little faith that this is going to work. Alright, so I can see where this is in relationship to this hole, that way, because this whole thing's going to slip when I whack it, but see if it moves. No, that's not moving. I'm not even going to bother. Slap this into the mill and use that as a vise. Well, I had to unbury the Wells Index. Kind of had all this junk piled up in front of it because I didn't think I was going to be getting back to it this soon. Didn't know that luck was going to be with me as far as finding a parts machine so close to home, so cheap. Anyways, I had forgotten about what a pain in the butt it is getting a quill assembly in. That spline shaft has to go up, and if the alignment's not exactly right. So I think what I had to do last time on this, if memory serves me, is I had to loosen up part of the top end, the head here. I think it might have been these three nuts here, and that allowed this whole part right here to shift around loosely enough so I could get that to line up and go in. I'm having a real hard time getting it in. So what I did was I put the head vertical. I had to tilt it over to ease removal of the quill. Tilted the head vertical. I brought the knee, I put this in as far as I can get it to go. I put a block of wood underneath the edge here, and I brought the knee up so that this is wedged in there, tight enough so it shouldn't turn. And I think I can get the wrench on there with the pins, into the pins, and tap it and get it to loosen up. At least that's the plan. If I can avoid moving this cabinet, I will. Now, so I can see what this is turning. Yeah, that worked. The only problem is the block of wood is now in the way of my wrench, but I think it's loose enough now I might be able to take it back up and do the rest of the bench. Yeah, it's unlocked enough. Alright, pull it out, put it back on the bench.